This is the Turf Zone Podcast, your central information and news hub, bringing together professionals from turf associations across multiple states to share things to help you in your business. Brought to you in partnership with our friends at the Alabama Turfgrass Association. Now, let's get in the zone.
Welcome to the Turf Zone. In this episode, we feature an article titled, Looking to the Future, Technology and Equipment of the Future. The Need for Lawns and the Equipment to Maintain. The evolution of mankind has intrinsically been tied to the development of turfgrass. Thousands of years ago, early man used the advantage of low-growing turf across savannas to stalk their prey and watch for approaching danger. During medieval times, only grass was allowed around castles, so anyone approaching could easily be seen. The early modern era saw great lawns and gardens fill the landscape around palaces and public malls. All the while, the only practical way for most people to maintain turfgrass through the mid to late 1800s was by grazing animals and/or scything. However, scything was done most effectively when the grass was wet. Some say the commercial turf equipment industry was born in the mid-1800s when Edwin Budding re-engineered a rotary cutting machine used to remove nap from carpet to cut turfgrass. This first-generation mechanical lawnmower could cut dry grass. The race for better, faster, bigger, stronger, safer, smarter, more efficient turfgrass equipment had started, and it continues today. What turfgrass managers have witnessed the last 30 to 40 years. Any member of the Alabama Turfgrass Association approaching retirement today has seen amazing advancements during their career. Here is a partial list of the next new innovation that propelled our industry forward, as submitted by several of our Alabama Turfgrass Association colleagues. Golf and sports fields. Cable steer greens mowers, pull-behind rolling drum aerifiers, independent hydraulic aerifiers, hollow tine, solid tine, slicer and spiker variations, core and thatch collecting equipment, drill and fill aerifiers, air, sand, and water injectors, rotary quaking decompaction equipment, silt drainage equipment, pull-behind and independent top-drop top dressers of various sizes, rotary top dressers, sprigging machines, turbine-type debris blower, greens mowers with GPS steer, hydraulic triplex greens mower, cruise control on rough and fairway mowers, phrase mowers, electric and hybrid equipment, sprayers with GPS guidance, utility vehicles, infield groomers, lightweight rollers, gang rollers, the progression of drive systems from chain to belt, to hydraulic, to electric, LED lights, battery-operated golf carts, mowers, hand tools, including mechanical tools, equipment lift, tools that measure playability, such as the stump meter for ball roll and the Clegg hammer for surface hardness, laser-guided grading equipment, turf planners, large vacuums, sweepers with hydraulic dump beds, drones with cameras, sensors and sprayers, lawn care and landscape, line trimmers, stick edgers, mulching mowers, backpack blowers and sprayers, chem lawn spray gun, foam marking boom sprayers, walk behind mowers, zero turning radius mowers, foam filled tires, ride on spreaders and sprayers with boomless spray nozzles, slope mowers, remotely operated slope mowers, skid loaders, articulating skid loaders, big roll installation equipment, dump trailers, live bed trailers, hydraulic trailer ramps, power augers, rollover protection systems, safety cutoff bars, pressure activated cutoff switches, neutral start gear shift, chainsaw chain brake, sod production, walk-behind harvesters, tractor-mounted harvesters, harvesters with automatic stackers, fully automated one-man harvesters using GPS guidance, cutting and stacking sod, big roll harvesters, truck-mounted forklifts, wide rotary mower up to 36 feet, sprayers with GPS guidance, rate control and shutoff, variable rate lime and fertilizer application in conjunction with grid sampling, center pivot irrigation and center pivot irrigation controlled using a smartphone, irrigation, PVC and HDPE pipe, pin and dial irrigation timer, advancements in glue and cleaner, hot and fast curing, heavy, load-bearing valve boxes, various types of quick couplers, swing joints, novelty PVC couplers, e.g. flow span, drip irrigation especially for landscapes and parking lots, submeters to separate irrigation water from other uses, digital controllers, smart irrigation controllers, soil moisture and salinity sensors, sprinkler head check valves, valve in heads, impact, spray, stream, rotating, fixed and adjustable arc spray heads, master valves, leak detection monitoring devices, two-wire irrigation systems, control of the irrigation and lighting systems through the controllers using a cell phone, the use of the old world cistern idea to store water, testing criteria for water sense labeling for sensors and controllers, real-time pressure sensing, precipitation sensors, variable frequency drives for pump station applications, water audit software, integrated remote pump monitoring, mechanical joint restraints for piping systems, and trenchers of all sizes. All of the aforementioned innovations were amazing, huge, labor-saving advances for the turfgrass industry. But let's not forget what technology has done. Many managers never even learned to type during their formative years, but as computer and cell phone use exploded, even our most seasoned colleagues became proficient with technology. Everything we do evolves around the benefits of applied science. Today, technology touches every aspect of our lives, keeping time, storing employee data, customer files and inventory, aiding with design, sales, and advertising, helping with identification of plants and pests, providing information, pictures, and videos on any subject at a click. And let's not forget communication. Emailing and texting are taken for granted today. Faxing is almost as rare as MSMA. Technology, computers, laptops, digital tablets, pagers, beepers, two-way radios, mobile phones, flip phones, smartphones, digital cameras, GIS and GPS, software for all types of applications, podcasts by the thousands, such as the turfzone.com. Various apps such as Google Maps, Sun and Shade Analyzer, Landscaper's Companion, Sunseeker, Lawn Starter, iScape, along with other augmented reality apps. Weather websites such as Storm Tracker and Windy. Social media platforms, Facebook, Twitter, Instagram, YouTube, Pinterest, LinkedIn, Snapchat, WhatsApp, etc. As Alabama Turfgrass Association members have witnessed, the advances in equipment and technology over the last 30 to 40 years has been unprecedented in turfgrass history. Past innovations have helped the turfgrass managers in more ways that can be mentioned or explained in this article. So what's next? Where do innovations originate? David McCall, PhD, Virginia Tech, answered that question this way. New ideas originate from need or from somebody seeing a better way to get things done. Sometimes that comes from a golf course superintendent, a sod producer, a university researcher, an equipment manufacturing engineer, a sales rep, or the guy weed eating along fence lines. In the university setting, we get paid to come up with new ideas for improving how things are done and then testing those ideas. Sometimes they work, sometimes they don't. However, we can come up with the most high-tech solutions possible, But if the solution is worse than the problem, or the solution is highly impractical, then what's the point? A lot of the truly game changing ideas come when there is strong feedback from multiple players who think about the end goal differently. Strong collaboration is key. Chase Straw, PhD, Texas A&M, stated, "Some inventions are revolutionary and completely new. Others may be a new feature for an existing tool or piece of equipment, such as GPS and auto steer on sprayers and mowers, or GPS-equipped soil moisture sensors. In some cases, inventions may be a simple feature to make maintenance easier or more ergonomic. Dr. Straw sees cutting-edge technology and equipment advances being used in precision agriculture, PA, and wonders why it's not being used in precision turfgrass management, PTM. He mentioned as an example concepts of using sensors as part of irrigation systems. Started in PA to better utilize this precious resource in making management decisions, and now it's becoming more commonplace in PTM. When advancements in PTM do occur, many, if not most, are often found first on golf courses. Why? Well, the answer is clear for two reasons. One, the United States Golf Association reviews worthy research proposals every year, spending about $1.8 million across a variety of projects. Two, the bottom line is that money drives research studies, and the bulk goes to agriculture. However, the research usually trickles down to golf first and then to the rest of the turfgrass industry. For those reasons, Dr. Straw said, "I spend a lot of time talking with golf course superintendents discussing their issues as an opportunity to identify further areas of research." Interestingly, research funding could have a new source. The U.S. sod industry's formation of a checkoff program has the potential to raise approximately $12 to $14 million each year for research, promotion, and education of natural grass. If the checkoff program is approved through a nationwide referendum of sod producers, the U.S. Sod Checkoff Board will be created with 5 of the 13 sod producer board members being from the South, according to Dr. Casey Reynolds, TPI Executive Director. He stated a U.S. sod checkoff program has the potential to change the face of natural grass research and promotion by creating the largest single funding source of its kind in the world. Sod producers would oversee and manage the program. It could fund large-scale research and promotion locally and nationally on a scale that is not currently feasible. The USDA also funds a good deal of basic research, but not so much applied research. It's also worth noting that USDA's annual contribution to turf research varies year to year. The biggest contributor to turfgrass research dollars is private business investment. Motivated by increased sales, market share, and ultimately profit, they are always looking for the next big innovation. Many of these large companies put millions of dollars into their own research division budgets to develop new innovations for equipment and technology. Private business also funds universities to develop research and test new products. Dr. Straw stated the fact is the turfgrass industry is a small niche market compared to all of agriculture. So the other larger sectors of agriculture usually see the benefit of new ideas first, such as the latest in sprayer technology, automized anything, and even drone technology. But let's not forget the average person's ability to see the need for a better way. Some individuals have been responsible for the next industry-changing idea. Take, for instance, the string trimmer. In 1971, George Ballas fashioned the first weed eater by attaching pieces of heavy-duty fishing line to a tin can bolted to the rotary head of an edger. Since that moment, this one simple invention has touched everyone involved with turfgrass maintenance. In 1977, Ballas sold his invention for an undisclosed amount after having an astounding $41 million in sales during 1976. What turfgrass issues are being addressed through innovation today? The development of equipment and technology for turfgrass has been an ongoing process since man started the quest of taming the lawn. Many of the issues addressed over time remain roughly the same: efficiency, cost benefit considerations, maneuverability, safety, and environmentally friendly, to name a few. Today, more than ever, innovative ideas related to turfgrass research are juxtaposed with the ever increasing goals of precision agriculture, PA. Those goals have progressed to improve site specific management based on obtaining site specific information. This mindset has also spilled over to the growing concept of precision turfgrass management, PTM. This subject was discussed in what some turfgrass researchers view as a seminal article entitled Precision Turfgrass Management: Challenges and Field Applications for Mapping Turfgrass Soils and Stress by Robert N. Caro, Ph.D., et al., 2010. There, the authors stated primary turfgrass cultural practices are irrigation, fertilizer application, cultivation, mowing, and pest control. As in agriculture, turfgrass managers worldwide are interested in ways to improve input efficiency, especially related to the primary cultural practices, and to minimize any potential negative environmental aspects. And by input efficiency, they refer to less fertilizer, pesticides, and water being used, resulting in less energy and labor as well. Rising cost and short supplies of all materials, along with the trend toward PTM, have mandated that much of the equipment and technology innovations for turfgrass application address the reduction of inputs to only areas where need exists. Regarding this, Caro et al. 2010 gave us more clues about future innovations for turfgrass that are still relevant today. To achieve input efficiency, one approach adopted by PA is through the use of Site-Specific Management Units, SSMUs, delineated within fields or management zones, which are areas with similar soil, topography, microclimate, and plant response. PA, as does PTM, aims to obtain detailed site-specific information by mapping important variations in important soil and plant properties to enable better site-specific management. Therefore, reliable maps of soil conditions, topography, and plant yield based on adequate sampling are necessary to delineate SSMUs accurately. This is to say that within a golf course, sports complex, sod farm, or any large turf area, there could be as many as 4 to 6 or more distinct SSMUs, each of which might require different levels of inputs. Sensor technology would be used to attain this information, along with Geographical Information Systems, GIS, database development, and graphic display to pinpoint areas having fertility issues, pest problems, drought, compaction, etc. Using equipment with variable rate application, VRA, technology, different SSMUs would receive different rates of application based on their precise location, thus using inputs more precisely. It is obvious that sensor innovations will be used more and more in the future to monitor the many aspects of plant and soil attributes. Operations such as spraying, spreading, irrigating, arifying, mowing, and harvesting could all use data from either stationary or mobile, aerial and ground, sensors with data access through direct downloads or wireless communication. Regarding a completely different technology, battery-powered equipment is really starting to show strong improvement. Some areas of the country are being forced in that direction due to air and noise pollution regulations. Even in Alabama, some larger landscape maintenance companies have crews that only use battery-powered equipment because of the noise restriction during certain hours of the day at apartments, schools, nursing homes, hospitals, offices, and residential areas. Part 2 of this article will discuss specific equipment and technology advancements. For all resources associated with this article, check out our show notes. Don't miss an episode. Subscribe on Apple Podcasts, Spotify, or wherever you get your podcasts. You can also visit us at theturfzone.com.
You've been listening to The Turf Zone. For more episodes of The Turf Zone, visit theturfzone.com and subscribe on Apple Podcasts, Stitcher, or your favorite podcast app.